Hello guys, welcome back. So today I'm going to show you the progress of the automatic switching box, the Sbox12, the status of the this project. So if you're following my etracer group, you'll notice that I already used this switching box in the Expo show in Chicago in April. So basically the hardware was designed like 3 months ago, around February. But there's still a lot of chore to do to make it a product. For example, I need to design a bootloader for the firmware. I need to make the firmware upgradable. I have to do the chassis design, and most important, I need to the software actually need a redesign. So and the software task is very big. So I was thinking it might not be the good idea to wait until the software is finished, because with the current etracer software and with the help of a switching box, I think it will satisfy probably like 80% of the user's need. So I'll explain that in further detail later. So today let's start with playing with the switching box. So today we are going to test 3 different type of tubes. And so before we start testing, let's have a look at the hardware configuration. Okay, so this is the switch Sbox12. It can support up to 12 pins. Okay, so for the standard etracer configuration, we only have up to 10 pins for the tube sockets, but there's TV tubes like for TV applications that can have up to 12 pins. So in order to support that kind of tubes, I made the switching box to support a maximum of 12 pins. And the connection is quite simple. Basically, what the switching box does is it routes the output of the etracer signal to the pins on the device under test, respectively. So we route the output of the etracer PCB to the upper row, and the output is routed back to the pins on the tube sockets. This is a look of the back panel. So inside the switching box, I put a USB hub chip. So basically, there's a USB hub inside the switching box, so we don't need to run 2 USB wires to the PC. We connect the USB connector of etracer to the USB hub, and then we only need to run a USB cable to the PC. This power cord is for the etracer. So the connection is very clean. This switching box is can be powered by USB power only. So according to the standard, each USB port can support 5 volt up to 500 milliamp. So it's more than enough to power the internal relays and the USB hub. And if in rare occasion, if the USB port is not standard compliant, or it might have trouble to power the Sbox12, you can use a external DC power supply to power switching box. This switching box. So the DC jack accept from 9 volt to 30 volt DC. So we can use the chassis fan power supply at 12. It's a 12 volt. We can run a wire from the power supply to this input jack. But I think under normal operation, you probably never need to do this. Okay, so that's for the connection. So now we are ready to run some tests. So like what I said earlier, there's with the switching box, the test paradigm or the test approach can be totally different. But the software task is very big. So so for this initial version, I only modified the original etracer software to incorporate the switching box. So we can enable the switching box in the config window. So here we enable switching box, and here we have a drop-down value. The software will detect the switching box automatically, and you can enable it and apply it, and that's it. So the way it works is every time we download a tube configuration file, if you remember, the software has the routing table here for the wires. So let's, for example, load a 12x7 file. Okay, you can actually hear the clicks of the relays. So here we have a table, and with this column is a pin names, and this column we select the where to connect to those pins. For example, pin 1 is the trap, the plate 1, the plate for trap 1, and so we for the number 1 unit, so we connect pin 1 to HV1. Pin 2 is grid, so we connect to negative voltage supply. Pin 3 is okay, so we connect to ground, and so on and so forth. So basically, the after a download of the configuration file, if the switching box is enabled, it will dial in the routing to the switching box. So if we don't have the switching box, we have to route this cable manually. Okay, so now we are ready to test the 12x7. Connect. Turn on the heater. Okay, so here you can see the heater current is already having a non-zero reading. So here I'm going to download the calibration file for this PCB quickly. Okay, so today we are going to do quick test only, because we don't want to waste much time on the full scan, and we don't wait for the heater to fully heat up the cathode, because we only want to I only want to show you the functionality of the switching box. So now we are ready to run the test. Okay, so the test is done. So next we are going to test the 6L6. So we download. First we take off the 12x7, then we download the 6L6 configuration file. 6L6. Okay. And plug in the tube, turn on the heater, so we don't have to do this routing. And you can see we already have the reading on the current. And now we are ready to run the test. Okay, and we get a reading here. The test is done. Okay, so that's 12.6L6. Now next we are going to measure a 6C4. It's a 7-pin miniature tube. It's like the half of a 12X7, 12AU7. 6C4. Okay. Heater on. Okay, we can see the heater reading here. Okay, so we are ready to run the test. Okay, test done, and we have the readings here. Okay, so that's it. So as you can see, the with the help of the solution box, the testing become quite easy because we only need to plug in the tube and click a button, and we can get the result really quick. And with the current software, etracer software, it has a limitation. So I'll explain that in detail. Because with theoretically, with a device like this switching box, we can. Okay, so for the current etracer software, we can only test up to 2 elements simultaneously. We for example, twin triads. So the requirement is the both element has to be identical. Like a twin triad, like 12X7, both section has a identical configuration, identical characteristic. But there's like tubes, like for television applications, they have up to 3 elements, and each element is different. For example, there can be one diode, one triad, and one pentode encapsulated in one envelope. So ideally, with we can configure the etracer to with each different with one specific with respect to one specific element, and test it. And after the test is done, we can switch to the next element and test it again, and switch to the next element and test it again. So it's not possible with the current software, etracer software. So that's something I need to work on. But I mean, so currently, if we want to test a tube with 3 elements, we have to download the configuration file 3 times. Each file is configured for a specific element. So that's a limitation. The new software might it's a big, like I say, it's a big project. It might never become complete. It might never be completed, and for like I would say for like 80% or 90% of etracer user, you probably don't even need that. So that's why I decided to make a solution box available now instead of waiting for the software to be finished. Okay, that's it for the solution box 12. I hope you like my video. I'll see you next time. Bye.